What if your students could take what's in their imaginations and hold it in their hands? What if they could feel it, test it, measure results, and improve their designs? How much more could they learn? In over 3,500 educational institutions worldwide, Stratasys 3D printers are changing what students think they can do by giving them fast, accurate, durable, three-dimensional models of their CAD designs. Models that give students a deeper, more comprehensive understanding of how science, technology, engineering, and math work together. We're enhancing curriculums by taking theory into reality, giving students the opportunity to make design decisions, test them, and improve them, using the same technology professional designers have chosen. From an early age, students can solve real-world problems by creating real 3D solutions and learn while they're having fun. Starbase is a hands-on curriculum that introduces aerospace and technology concepts to 4th through 6th grade students. Nationwide, Starbase has invested more than $1 million to add Stratasys 3D printers into its curriculum. Focused on teaching STEM skills, Starbase uses Stratasys 3D printers to integrate STEM concepts and teach problem solving through iterative learning.
We can take them from these math, science applications of concepts into how they can really impact their decisions, and then hopefully that will let them see that this is how people are doing work in the real world.
The 6th grade program, they design their own fins on CAD and then they print them off on an interdimension printer. So they actually get to launch the fins that they've designed on CAD, which is pretty cool.
3D printing has been really cool for our program because we're always trying to make our engineering activities and our science activities actually applicable, how that they can actually reflect some change in the design.
People are hungry for this, students are hungry for this, and schools are, because it's a really well-crafted curriculum. It's aligned with state and national standards as well. It's really getting them excited about engineering, seeing science as a way to solve problems, allow them to work in teams, give them a story to follow, kind of a piece of the puzzle to kind of get them to the end goal.
Matt Bunting, a student in robotics and neural systems at the University of Arizona, has been interested in robotics since he was 12 years old. In middle school, he saw his first hexapod, and it wasn't until he enrolled in a cognitive robotics class that he finally had a good excuse to build one.
I'm able to make very complex parts using something called a 3D printer made by Dimension. And the way this works is it actually extrudes layer by layer small amounts of plastic. So you can see that you can really make any sort of complex shape with the 3D printer. And these are very rigid pieces that can be used in robotics, casings for other embedded projects.
Printing models with a Stratasys 3D printer is fast, reliable, and easy. Our Catalyst EX print driver works with any level of CAD software, from the simple versions used in elementary schools to professional-grade industrial CAD programs. Catalyst converts the STL output from a 3D CAD program into paths that guide the printer's extrusion head. At the same time, it automatically slices models and creates any necessary support structures. Just click Print, and the model begins building. Using our patented FDM technology, filaments of ABS modeling material and soluble support material are fed up to the printer's extrusion head. There, the materials are heated to a semi-liquid state, forced through dual extrusion tips, and precisely deposited onto the modeling base in layers as thin as a human hair. The print head moves in XY coordinates, and the modeling base moves down the Z-axis as the model and its support material are built from the bottom up, layer by layer, giving ideas shape and durability. Once the build is complete, it's ready for the Wave Wash support cleaning system. Wave Wash removes support material automatically using a combination of heat, agitation, and an eco-friendly detergent solution in a fully contained, hands-free system. In just a matter of hours, students can take their ideas into the real world. They'll have a fully functional, real ABS plastic prototype to feel, test, analyze, and improve. Josiah Thomas and Jonathan McLaury, undergraduates at the University of Alabama, Huntsville, used iterative learning to improve their remote control fire detection helicopter.
So we had this fire sensor here. We needed a way to be able to remove the lens quickly. So we designed some threads onto there. The Fortis is real good at accurately reproducing CAD models. So we were able to get some really nice threading features on here. We have some older iterations. They don't thread, and we needed a way to be able to secure the lens on very well. The threads worked out really nicely for that.
I don't really know how we would have accomplished this except maybe injection molding, which would have taken hours and hours more because you would have had to make a CNC mold to actually inject the part into. This is very easy. You just sit there, you plug in your CAD model and print it, and it's good to go. Come back about 6 hours later and you've got a part.
Steve Collins, prototype development specialist at the University of Alabama, Huntsville, supports over 1,000 students, both undergraduate and graduate, in mechanical and aerospace engineering.
The Fortis machine has allowed us to do things that first of all, we wouldn't have been able to do any other way. It's allowed us to produce models with a complexity that we could never have hoped to achieve by any other means. Before we had the Fortis machine, there was a far greater limit placed on their imagination and the sorts of things that they could develop because they had to have the manual skills to be able to produce those parts. Since we've had the machine, we've been able to produce very complex models with nothing more than the CAD file. As far as return on investment, all I can say is I really don't know what we would do without it. You can't necessarily, for us, put it in dollars and cents. The ability to produce models accurately in functional materials with a minimum of post-processing issues or environmental issues. We're able to work with the software. It's quick, it's easy. Students can learn to operate it without any great difficulty. It's the best combination of factors out there, without a doubt.
One of the many graduate programs Steve supports is the NASA-sponsored competition, the U.S. Launch Initiative, where students compete in rocket design.
And we're using the Fortis rapid prototyping technology to build a lot of the structural components of the rocket, especially the nose cone. We're doing this on a 5% scale. And so the rapid prototyping technology allows us a lot of detail and a lot of flexibility as well as speed and accuracy in our modeling. We can make changes to the components quickly and get new parts back easily.
If you are involved in projects in which students have to produce things that they have designed, or if they're involved in design competitions where having physical models of the CAD models, you need the ability to produce those models accurately, inexpensively, and in preferably functional materials. That's where this machine excels.
In fact, having a professional-grade 3D printer has served as a recruiting tool for the University of Alabama, Huntsville, for both potential students and professional customers. When they acquired their Stratasys 3D printing system, word in the surrounding engineering community spread quickly. Soon they had numerous aerospace and technology companies knocking on their door.
We've done work with BAE Systems. We've done work with the Army and some entities within NASA. We've worked with companies that prefer to remain nameless, but it's very interesting work, and it is stuff that allows our students to work with these companies to get their foot in the door. We've got students working directly, interacting with engineers from these companies and institutions, one-on-one, to produce models for them, and you can't beat that when it comes to your resume.
Stratasys believes in students. We have a long-standing commitment to supporting the engineers and designers of tomorrow. By putting professional-grade technology into the hands of students, we're preparing them for the real world. Our 3D printers captivate minds, spur creativity, and provide experiential learning. They encourage teamwork and collaboration. They teach hands-on, iterative problem-solving skills. They provide a deeper understanding of science, math, and technology. With teachers, our tools turn curiosity into confidence. Ask your Stratasys representative about special educational packages. Find out how easy it is to bring 3D printing into your classroom.